What would make Italy move from monitoring a restless volcano to ordering one of Europe's most complicated evacuations? Would it take a larger earthquake, a faster rise of the land, a sudden change in volcanic gases, or several warning signs appearing together? And if authorities were forced to clear hundreds of thousands of people from the densely populated districts surrounding Naples, could the evacuation actually be completed before dangerous volcanic phenomena began? Those questions have become more difficult to dismiss after Campi Flegrei experienced its strongest instrumentally recorded earthquake on July 31, 2026. The magnitude 4.7 event was not an eruption, but it exposed just how intensely the volcanic system is still deforming and how closely scientific monitoring is tied to civil protection planning. The critical point is that the volcano is not currently at the red alert level. The official alert remains yellow, corresponding to a state described as medium disequilibrium. The system has produced stronger earthquakes, continued long-term uplift, and significant impacts on buildings and infrastructure. The July earthquake forced hundreds of people from their homes, while monitoring data show that the caldera continues to rise. Campi Flegrei is not a conventional volcanic cone standing isolated above an empty landscape. It is a vast, active volcanic field stretching across the western side of the Naples metropolitan area, incorporating towns, roads, ports, railways, industrial districts, residential neighborhoods, and densely occupied urban areas. Much of the volcanic system is hidden beneath the surface, while parts extend beneath the Gulf of Pozzuoli. That creates a unique hazard because volcanic unrest is unfolding underneath a heavily populated environment rather than in a remote wilderness. The official Italian emergency plan identifies a red zone containing approximately 500,000 residents, while the wider yellow zone contains more than 800,000 people. The scale becomes clearer when the July 31st earthquake is placed into its proper setting. The magnitude 4.7 shock struck at a depth of roughly 2.4 kilometers, or about 1.5 miles, according to the INGV earthquake database. It occurred at 7:46 in the evening local time and was followed by a sequence containing hundreds of smaller earthquakes. Another magnitude 3.8 event occurred later that evening. Because Campi Flegrei earthquakes are generally shallow, even moderate magnitudes can produce intense shaking close to the source. In this case, the shaking was strong enough to cause damage, injuries, and disruption across the Pozzuoli area and surrounding parts of metropolitan Naples. The human consequences were immediate. Italy's Civil Protection Department initially reported 10 lightly injured people and damage to unoccupied buildings, along with a partial collapse of a high-voltage electricity pylon in the Agnano area. The Pozzuoli pier was temporarily declared unusable, and minor landslides and rock falls were reported. By August 1st, authorities reported 26 injured people and approximately 300 residents who had been forced to leave their homes while structural inspections continued. INGV subsequently reported that 11 buildings were evacuated and that around 800 people had been compelled to leave their residences. Those figures illustrate an important distinction. The earthquake did not trigger a regional evacuation, but it did produce a real displacement event inside an already vulnerable volcanic zone. Hundreds of residents leaving damaged or potentially unsafe buildings after an earthquake is one thing. A formal volcanic evacuation of the red zone would be something entirely different. Under Italy's national emergency plan, preventive evacuation becomes the principal protective measure if the volcanic emergency reaches the alarm phase. The red zone is defined around the potential danger from pyroclastic flows, which can travel rapidly and at extremely high temperatures. Authorities therefore cannot wait for a visible lava flow approaching neighborhoods before moving people. The evacuation would have to be initiated in advance if the scientific assessment indicated an imminent eruption. That is why the most important change at Campi Flegrei is not simply the magnitude 4.7 earthquake. The deeper concern is the combination of seismicity and deformation that has developed over years. Since 2005, the caldera has been undergoing a renewed phase of uplift known as bradyseism. Since 2018, the upward movement has been accompanied by increasing seismic activity and changes in deformation rates. According to Italy's Civil Protection Department, some phases have exceeded 30 millimeters per month, equivalent to more than 1.18 inches per month, before slowing to values generally around 20 millimeters per month or lower. The system has therefore not returned to a completely quiet baseline. The latest deformation figures make the situation even more striking. At Rione Terra in Pozzuoli, the point identified as the area of maximum caldera deformation, the cumulative uplift reached approximately 167.5 centimeters, or about 5 feet 6 inches, by the end of July 2026. Around 30 centimeters, or nearly 12 inches, of that total movement occurred since January 2025. This does not mean the entire Campi Flegrei region has risen uniformly by 5 feet 6 inches. Deformation varies spatially, and the measured uplift reflects the complex response of the volcanic system. Nevertheless, such a large cumulative change provides a powerful indication that the subsurface processes driving the unrest have persisted for years rather than appearing as a brief disturbance. Bradyseism can look deceptively simple when reduced to the phrase, "the ground is rising." Underneath the caldera, however, the process involves interactions among volcanic fluids, heat, fractures, rocks, and pressure. When hot fluids move through fractures and porous rock, pressure can change within the hydrothermal system. The rocks respond by deforming, and that deformation can be detected by instruments at the surface. Magma-related processes can also contribute to pressure changes at depth. Scientists therefore do not interpret uplift as a direct measurement of a giant reservoir filling toward the surface. It is one piece of a much larger puzzle that must be evaluated alongside earthquakes, gas chemistry, temperature, and other observations. The earthquake sequence adds another layer. INGV reported that 426 earthquakes were preliminarily recorded in Campi Flegrei during July 2026. Most were extremely small, with 353 events, or approximately 83%, having magnitudes below 1 or magnitudes that could not be reliably determined because their signals were too weak to distinguish clearly from background noise. 61 earthquakes fell between magnitude 1 and 1.9, 7 reached between magnitude 2 and 2.9, 4 were between magnitude 3 and 3.9, and 1 reached magnitude 4.7. The important point is not simply the number of earthquakes, but the occurrence of the strongest event yet recorded by the instrumental network. The magnitude 4.7 earthquake also demonstrated the value of the dense monitoring network operating across the urban environment. INGV reported that the July event was recorded simultaneously by all stations in the urban accelerometric network. The instruments provided detailed measurements of ground shaking, allowing scientists to reconstruct how the motion varied across the affected area. At some locations, measured peak ground acceleration exceeded 80% of gravitational acceleration. Such data are valuable because the consequences of an earthquake are controlled not only by magnitude, but also by depth, distance, local geology, building vulnerability, and the characteristics of the shaking itself. This is where infrastructure becomes part of the warning system. Roads, bridges, power networks, ports, railways, and buildings are not merely passive victims of volcanic unrest. Their condition provides authorities with information about how deformation and earthquakes are affecting the human environment. At Campi Flegrei, prolonged uplift can impose stresses on structures and underground systems, while shallow earthquakes can produce abrupt additional loading. The July earthquake damaged buildings and disrupted electricity infrastructure, while maritime and railway operations around Pozzuoli also experienced difficulties. None of these impacts proves that an eruption is approaching, but they demonstrate that the volcanic crisis is already capable of creating serious consequences without an eruption occurring. The most important warning against exaggeration is that Campi Flegrei has experienced major unrest before without progressing directly into an eruption. The current period of uplift began in 2005, while significant modern bradyseismic crises occurred in 1970 to 1972 and 1982 to 1984. The seismicity and deformation can therefore fluctuate over time. A period of accelerating movement does not provide scientists with a simple countdown clock. There is no scientifically reliable rule stating that a particular amount of uplift or a particular earthquake magnitude automatically means an eruption will follow. That uncertainty is precisely why authorities rely on combinations of parameters and predefined alert stages rather than a single dramatic measurement. Italy's alert framework reflects that complexity. The volcanic alert system uses 4 colors: green, yellow, orange, and red. These correspond to progressively greater levels of volcanic disequilibrium and escalating concern about possible hazardous activity. The current yellow level indicates that monitored parameters are above their baseline and that the volcano is in a state of medium disequilibrium. Under the operational system updated in 2025, yellow corresponds to the attention phase, which involves strengthened monitoring, continued assessment of the volcanic state, verification of civil protection measures, and prevention activities. It does not automatically mean that an eruption is imminent or that residents should leave. The next stages are much more consequential. A move toward orange would indicate stronger disequilibrium and would trigger progressively more intensive preparations. Red represents a far more serious condition associated with a pre-eruptive state and imminent eruption risk. At that point, the operational response would escalate to the alarm phase. The Italian Civil Protection Department has explicitly stated that the pre-alarm and alarm phases are declared by the President of the Council of Ministers. In other words, a mass evacuation is not something a local mayor simply announces because a large earthquake has occurred. It is embedded in a national decision-making structure that incorporates scientific assessments and civil protection planning. The evacuation challenge is enormous. Approximately 500,000 people live inside the designated red zone. That population includes the communities of Pozzuoli, Boccoli, Monte di Procida, and Quarto, parts of Giugliano in Campania and Murano di Napoli, and numerous districts of Naples. The yellow zone extends even farther, encompassing more than 800,000 residents who could face substantial ashfall during an eruption. The potential movement of such a population cannot be treated like an ordinary emergency evacuation. It requires transportation corridors, reception areas, medical assistance, communications, accommodation, fuel, traffic management, special arrangements for vulnerable residents, and coordination across multiple municipalities. There is another complication. The safest evacuation route may not always be the fastest-looking route. Dense urban development means roads can become congested rapidly, particularly if residents attempt to leave independently at the same time. Rail and maritime infrastructure can provide additional options, but those systems can also be affected by earthquakes, deformation, or volcanic hazards. The July earthquake already demonstrated how quickly infrastructure can become unavailable when a high-voltage pylon is damaged or a port facility is restricted. An actual volcanic emergency would therefore require authorities to move people before the most dangerous phenomena arrive, while keeping routes functioning for emergency services and avoiding the chaos created by simultaneous uncoordinated departures. The presence of the Gulf of Pozzuoli adds another dimension. Campi Flegrei is partly offshore, and some of the seismicity occurs beneath or around the Gulf. That means the volcanic field cannot be understood purely by looking at land-based features. Earthquakes beneath the sea, deformation around the shoreline, and changes affecting ports can all become relevant to civil protection operations. The July event showed that maritime infrastructure can be disrupted even without an eruption. During a larger emergency, maintaining safe access through the Gulf could become an important component of evacuation and logistics planning, depending on the hazards identified at the time. Another crucial question concerns volcanic gases. Earthquakes and deformation attract public attention because they can be felt or measured directly, but changes in gas chemistry can reveal processes that cannot be seen from the surface. Campi Flegrei has a major hydrothermal system, and monitoring includes the composition of fumarolic and soil gases. Carbon dioxide, for example, can accumulate in areas where volcanic fluids rise toward the surface. Yet gas measurements must be interpreted carefully. A change in one gas parameter does not automatically translate into an eruption forecast. Scientists look for patterns across multiple measurements and compare them with seismicity and deformation to determine whether the volcanic system is moving toward a more dangerous state. It is tempting to imagine Campi Flegrei as a sealed container slowly filling with magma until something gives way. The real system is considerably more complicated. Fluids can migrate through fractures, rocks can deform, hydrothermal processes can generate pressure changes. Seismic faults can rupture as stresses evolve. Magma may be involved at depth without necessarily moving rapidly toward the surface. Several mechanisms can produce similar signals at the surface. That is why scientists cannot simply convert one earthquake, one uplift measurement, or one gas reading into a precise eruption prediction. The danger is real, but the timing remains uncertain. The July earthquake nonetheless changed the practical conversation because it demonstrated that the existing unrest can produce damage at a level that affects daily life. A magnitude 4.7 earthquake is not remotely comparable to the largest earthquakes on Earth, but at Campi Flegrei, the shallow depth makes the situation different. The earthquake occurred only a few kilometers below a densely populated urban environment. Buildings that have experienced years of deformation may also face a different level of vulnerability than structures sitting on stable ground. This means that even without an eruption, repeated seismic episodes can gradually increase the pressure on communities, infrastructure, and emergency systems. The sequence also continued after the main shock. INGV reported more than 200 smaller earthquakes in the hours following the magnitude 4.7 event, including the magnitude 3.8 earthquake later that evening. Additional events were recorded in the following days, and the observatory continues to publish real-time seismic maps. By August, the network was still recording earthquakes in the Campi Flegrei area, including events around magnitude 3. This continuing activity does not mean an eruption has begun. It does, however, show why monitoring cannot stop after the headline earthquake fades from public attention. Volcanic systems are assessed through trends, and trends require continuous measurements over time. There is also an important psychological dimension to the crisis. Residents do not experience volcanic unrest as a line on a scientific graph. They experience shaking during the night, cracks or damage in buildings, disrupted transport, inspections of homes, and uncertainty about whether the next earthquake will be stronger. When hundreds of residents have to leave their homes after an earthquake, the distinction between volcanic unrest and volcanic disaster becomes less abstract. This is one reason Italy has been conducting exercises designed to test how authorities would respond if the volcano moved from yellow toward orange and eventually red. The exercises are intended to expose weaknesses before a real emergency occurs. Those exercises matter because evacuation is not a single instruction. It is a chain of decisions that must function under pressure. Authorities must determine which areas are safe to enter, which roads remain usable, where evacuees should go, how vulnerable residents will be assisted, where emergency vehicles can operate, and how information will be communicated. Schools, hospitals, businesses, and transport operators all become part of the response. The national planning system therefore divides the region into zones and assigns procedures in advance. The purpose is not to predict exactly when an eruption will occur, but to reduce the amount of improvisation required if the scientific situation deteriorates rapidly. The existence of a red zone should therefore not be interpreted as evidence that authorities expect an eruption tomorrow. It is a planning boundary based on hazard modeling. The red zone identifies areas where pyroclastic flows could pose an extreme threat, while the yellow zone addresses the consequences of significant ashfall. In the event of an alarm, the red zone population would need preventive evacuation because the speed and temperature of pyroclastic flows leave little room for last-minute escape. The yellow zone presents a different problem, where ash accumulation could compromise vulnerable buildings and make roads difficult to use, potentially requiring temporary relocation in affected areas. What has changed, then, is not that Italy has secretly decided to evacuate 500,000 people. The more significant change is that the threshold for serious preparation has become impossible to ignore. The strongest earthquake yet recorded at Campi Flegrei has now occurred during a prolonged period of uplift and elevated seismicity. The cumulative deformation at Rione Terra has reached approximately 167.5 centimeters, or 5 feet 6 inches. Hundreds of residents were displaced after the July earthquake, and infrastructure suffered measurable disruption. These facts do not establish that an eruption is imminent, but they strengthen the case for maintaining a high level of preparedness. Scientists will therefore be watching several signals rather than waiting for one spectacular event. A sustained acceleration in seismicity would matter. A change in earthquake depths or locations could matter. A significant acceleration of ground deformation would matter. Changes in volcanic gas composition or emissions could matter. New thermal or hydrothermal anomalies could matter. None of these signals, considered in isolation, would necessarily force an evacuation. The greatest concern would arise if multiple independent observations began pointing in the same direction, indicating that the volcanic system was transitioning from its present state of medium disequilibrium toward a substantially more unstable condition.